Welcome to the Sheyas, your map.
Hi friends, today we are going to discuss increasing and decreasing functions. Differentiation, increasing and decreasing functions. The function f of x is increasing on the interval a to b if f dash of x greater than or equal to 0 for all values of x such that a less than x less than b. The function f of x is decreasing on the interval a to b if f dash of x less than or equal to 0 for all values of x such that a less than x less than b. So in a simple way, how can we say f dash of x greater than or equal to 0, the function f of x is increasing, and f dash of x less than or equal to 0, the function f of x is decreasing. Let us see this increasing and decreasing functions in the graph. In this graph, see the function is increasing. See, you can take any negative value, the function is increasing. At 0, again the function is increasing. At any positive value, the function is increasing. So in general, we can conclude that for all x belongs to R. So this symbol means belongs to. And R is a set of real numbers. A set of real numbers. Real numbers in the sense all real numbers. So how can you conclude? For all x belongs to R, the function f of x is increasing. So for all real values of x, the function f of x is increasing. See, in this graph, this point is minus 1 comma minus 1, and here this point is 1 comma minus 1. So here the graph is increasing from minus 1 to 0. Minus 1 to 0, the graph is increasing. And from 0 to 1, the graph is decreasing. So minus 1 to 0, the graph is increasing, and 0 to 1, the graph is decreasing. Hello friends. In the previous video, we have discussed the problems under increasing functions, and in this video we are going to discuss the problems under decreasing function. First problem: find the values of x for which f of x is a decreasing function given that f of x equals a, b and c, d. A, b, c, d functions. So once again I repeat the question. You have to find the values of x for which f of x is a decreasing function. So these are all decreasing functions, and what is the question? You have to find the values of x for which these functions are decreasing. Now I'll solve one by one all these problems a, b, c and d. Let us begin with a. So let us do the first problem in that. So what is given? Given that f of x is equal to 4 minus 2x minus x square. So the first step is to find f dash of x. So 4 differentiation is 0, and minus 2x differentiation is minus 2, and minus x square differentiation is minus 2x. So what is given? Given that the function is a decreasing function. So how can we write? Since f of x is a decreasing function, the condition is f dash of x less than or equal to 0. So what is f dash of x? minus 2 minus 2x less than or equal to 0. Now minus 2x I am keeping this side and taking this 2 to the other side. So here I am multiplying this inequality with a negative sign. So when you multiply this with a negative sign, minus of minus 2x will become 2x, and this, when you multiply this with a negative sign, this will become minus 2, and if you multiply any inequality with a negative sign, the inequality changes. So it will become greater than or equal to. Now keeping x as such, we can write minus 2 and take this 2 to the other side. So x greater than or equal to minus 1. So how we will conclude? For x greater than or equal to minus 1, the function f of x is decreasing. Next problem. So given the function is f of x is equal to 2x cube minus 3x square minus 12x. So same steps you have to follow. So what is the first step? You have to find f dash of x. So when you differentiate 2x cube, it is 6x square. Then minus 3x square will be minus 6x, and minus 12x differentiation is minus 12. So f dash of x, I can take this 6 outside and write it as common value. So remaining x square minus 6 and minus 2. So what is the question given? The function is a decreasing function. So since f of x is a decreasing function, the condition is f dash of x less than or equal to 0. So what is f dash of x? 6 x square minus x minus 2 less than or equal to 0. So I can factorize this and write it as 6 into x plus 1 x minus 2 less than or equal to 0. So here 6 into x plus 1 x minus 2 less than or equal to 0. So you can find the values, that is x plus 1 less than or equal to 0, or how can I write x minus 2 less than or equal to 0. So these are the two possible regions. So x less than or equal to minus 1 and x less than or equal to 2. So you might have seen in my previous videos, if you get two values like this, then what we have to do? We have to consider three regions. So considering three regions, that is, I'll tell you again how to consider the three regions. That is, x less than or equal to minus 1, x less than or equal to minus 1, x less than or equal to 2, x greater than or equal to minus 1, and x greater than or equal to 2. Then here we can write this x less than or equal to minus 1 as such, and we can link these two regions. These two regions we can link and write together as, that is, minus 1 less than or equal to x less than or equal to 2. And the third region, we can write the third region as such, x greater than or equal to 2. So altogether we have three regions. These two we have linked together and we have written as a single region. X less than or equal to minus 1 and minus 1 less than or equal to x less than or equal to 2, x greater than or equal to 2. So these are the three regions we are going to consider. So first we are considering the first region, x less than or equal to minus 1. So you have seen in my previous video of increasing functions. When you get two values, we have considered these three regions and we have checked in that whether the function is increasing or decreasing. So the same thing we are following here also. So what is the first step? X less than or equal to minus 1. So we are just taking some values and checking that whether this condition suits or not. So some values, let us take x is equal to minus 2. So if I take x is equal to minus 2, so what is your f dash of x? So once again I am writing the f dash of x. So 6 into x plus 1, x minus 2 less than or equal to 0. So this is your f dash of x and this is your condition, right? So when you apply this x is equal to minus 2 in this, just see what happens. Minus 2 plus 1 and minus 2 less than or equal to 0. So when you multiply this, you are getting 24 less than or equal to 0, which is invalid. So this f dash of x, so here f dash of x less than or equal to 0, this condition is not satisfied. And now we can consider the next region, x greater than or equal to 2. So here let us take some values greater than or equal to 2. So let it be 3. So this is your f dash of x. So f dash of x is 6 into x plus 1, x minus 2 less than or equal to 0. So you can substitute this 3 in the place of x. So what will you get? 6 into 3 plus 1, 3 minus 2 less than or equal to 0. So 6 into 4 into 1 less than or equal to 0. So 24 less than or equal to 0. So again you are getting invalid because 24 is not less than or equal to 0. And so f dash of x is not satisfied. Less than or equal to 0 is not satisfied. Now you have to consider the third region, minus 1 less than or equal to x less than or equal to 2. So let us take some values which is between this minus 1 and 2. So let us take x is equal to 1. So in the place of f dash of x, that is in the place of x, what we are writing? 1. So 6 into 1 plus 1, 1 minus 2 less than or equal to 0. So 6 into 2 minus 1 less than or equal to 0. Minus 12 less than or equal to 0. So now your condition, this is the valid value. So your condition minus 12 less than or equal to 0. So f dash of x less than or equal to 0 is satisfied. So f dash of x less than or equal to 0 is satisfied. So we can confirm that f of x is decreasing in this region, in this interval minus 1 less than or equal to minus 1 less than or equal to x less than or equal to 2. So when you are solving the problems, all these steps are not needed, but to get the exact value, better confirm by taking some values. So how I am concluding this? So we have seen that in this value you are getting f dash of x, that condition does not satisfy and you are getting a invalid value, and f dash of x is not satisfied, and for x greater than or equal to 2, f dash of x less than or equal to 0 is not satisfied. So only in the region minus 1 less than or equal to x less than or equal to 2, f dash of x less than or equal to 0 is satisfied. So we can conclude for minus 1 less than or equal to x less than or equal to 2, the function is decreasing. C problem, f of x is equal to 1 minus 27x plus x cube. So the same steps you have to follow. F dash of x is equal to, when you differentiate 1 it is 0 and minus 27x, differentiation is minus 27 and x cube differentiation is 3x square. So we know that these functions are decreasing. So we can write, since f of x is a decreasing function, f dash of x less than or equal to 0, this is the condition. So what is f dash of x? Minus 27 plus 3x square less than or equal to 0. So I am keeping 3x square as such. Then taking this 27 to the other side. So 27 x square less than or equal to 27 by 3. So x square less than or equal to 9. So once if you get this x square less than or equal to 9, this can be written as x square less than or equal to 3 square. So we are considering x square less than or equal to 9, and that can be written as x square less than or equal to 3 square. So since it is a square, it involves both negative and positive values. So first I am taking negative x less than or equal to 3 and negative x less than or equal to minus 3. Then positive x less than or equal to 3 and positive x less than or equal to negative 3. So these are the four possibilities. When you get the inequality which involves square, these are the four possibilities. Now in the next step what I am doing is, I am taking this inequality and multiplying this inequality with a negative sign. So just see how this inequality changes when I multiply this with a negative sign. This will become positive and this 3 will become negative 3. And when you multiply the inequality with a negative sign, the inequality changes. So you have converted this inequality to this. And just see how I am converting this. Again I am multiplying this inequality with a negative sign. So this will become positive and this 3 also will become positive. Since you have multiplied this with a negative sign, the inequality changes. And here you are keeping the inequality as such. So these are the four values you are going to consider. So here, in the next step, what I am doing is, x greater than or equal to 3, I am writing this region as such, and x less than or equal to minus 3, I am writing this region as such. But these two regions, I am linking together, minus 3 less than or equal to x less than or equal to 3. Minus 3 less than or equal to x less than or equal to 3. So now we have considered three regions. So you refer the previous problem what we have done. We have taken some values which is greater than 3 and we have taken some values which is less than or equal to minus 3 and we have taken some values which is between these minus 3 and 3, and then you can check whether the function is decreasing or increasing. So here you can do the same steps which I have followed in the previous problem. Here for x greater than or equal to 3, the condition is invalid, and for x less than or equal to minus 3, the condition is again invalid, and for minus 3 less than or equal to x less than or equal to 3, f dash of x less than or equal to 0 is satisfied. So I am concluding that for minus 3 less than or equal to x less than or equal to 3, f of x is decreasing. f of x is decreasing. So how can you write in notation, that is interval form? Minus 3 to 3, the function f of x is decreasing. So once again I am repeating, you can check, you can take some values and then check, then you can confirm for which value the function is decreasing. So here only for the value minus 3 less than or equal to x less than or equal to 3, the function is decreasing. So the next problem, f of x is equal to x plus 25 by x. So what is the first step? You have to differentiate. So when you differentiate it, x differentiation is 1. Then here this can be written as 25 into x power minus 1. So when you differentiate x power minus 1, you will get minus 25 by x square. Then since it is a decreasing function, you can write f dash of x less than or equal to 0. So what is f dash of x? 1 minus 25 by x square less than or equal to 0. So minus 25 by x square less than or equal to minus 1. So here I am doing the same thing. So when you multiply the inequality with a negative sign, what will you get? You will get a positive value 25 by x square greater than or equal to 1. Since you are multiplying this with a negative sign, the inequality changes and this will become 25 by x square and this will become positive 1. Then 25 by x square greater than or equal to 1. I am keeping as such, and you can write x square this way. So the same thing how I am writing is x, I am not changing the inequality, but I am writing the other way. 25 greater than or equal to x square, that is nothing but x square less than or equal to 25. Both are same. X square less than or equal to 5 square. So same like the previous problem, we have solved one problem, x square less than or equal to 3 square. C problem, the same steps should be followed here also. And we will be getting 4 regions, and accordingly we have to confirm for which region the function is decreasing. So here for minus, so x square less than or equal to 5 square, you are getting the value. So same like the previous problem we have to do. So if you get x square less than or equal to 5 square, you have to consider the 4 regions. Since it is a square, it involves both positive and negative values. So you have to consider the 4 regions, and then you have to finalize for which region the function is decreasing. You have to take some values and check. So here I have checked and finalized that for minus 5 less than or equal to x less than or equal to 5, the function is decreasing, but you have one more condition, except x is equal to 0. Why this x is equal to 0 is mentioned? Because what is your function? Your function is f of x is equal to x plus 25 by x, and your f dash of x is 1 minus 25 by x square. So this is a reciprocal function, and when you apply 0 in this, you will get 0 in the denominator, and once you get 0 in the denominator, the whole problem, that is the whole function, will be undefined. The whole value will be undefined, and definitely you won't get any value which is, that is f dash of x less than or equal to 0. you won't get a value f dash of x less than or equal to 0. Since it is a reciprocal function, you can't take the value x is equal to 0. And so I am concluding for minus 5 less than or equal to x less than or equal to 5, except x is equal to 0, the function f of x is decreasing. So how can we write in the interval format? F of x is decreasing on the interval minus 5 to 0 and 0 to 5. So here, see here, I have mentioned, that is, I have written as an open interval, which means that you should not include 0. So here the value is from minus 5 to 0 and not 0. And here the value is from 0 to 5 and not 0. This is the open interval. Okay. So you should not include 0. So I am concluding that f of x is decreasing in the interval minus 5 to 0 and 0 to 5. If you have any doubts, you can post it in the comment box. In the next video, let us discuss the greatest and the least values of a function. Thank you.
Thanks for watching. Like and comment. Please to subscribe to our channel.